Next, coming to the determination of the ash content in the food. Why we measure the ash content in the food? Ash determination of the food samples is the part of the proximate analysis necessary for the nutritional evaluation. This ensures the safety of foods, making sure that there are no toxic minerals present. The ash content in food can also impact the taste, texture, and the stability of the foods. So, it is vital to know the mineral content for quality control purposes. The estimation of the ash content in the food analysis is a classical method used to determine the total mineral content of a food sample. Ash content represents the inorganic residues that remains after the organic matter has been completely burned off. This analysis is crucial for assessing the nutritional value, quality, and the purity of the food products. What do you mean by inorganic residues? These are made up of elements or compounds that do not contain carbon. That means which do not contain carbon. It may contain nitrogen, oxygen, sulfur other than carbon. What is organic matter? It is a carbon based compound that comes from the remains of plants and animals or the chemical reactions. Ash content is the total amount of minerals present within the food. Minerals means the inorganic compounds that are present within the food such as calcium, sodium, potassium, chloride, etc. Organic compounds are the carbohydrates, lipids, proteins, nucleic acids, vitamins and the organic acids, whereas inorganic compounds are minerals. The estimation of the ash content is a fundamental aspect of the food analysis, providing valuable information about the mineral composition and overall quality of the food products. This ash is the inorganic residue remaining after water and the organic matter removed by heating in the presence of oxidizing agents. Coming to the principle behind determining ash content involves the complete combustion of the organic matter in the food sample, leaving behind the inorganic mineral residues such as ash. This is typically done at high temperatures in a muffle furnace. Even though it is of high temperature, minerals are not destroyed by heating and they have the low volatility compared to the other food components. Here, apparatus used are the silica crucible, weighing balance, tongs, electrical Bunsen burner, desiccator. This is the muffle furnace. It's a laboratory instrument that heats the materials to the high temperature while isolating them from the fuel and the combustion byproducts. And these muffle furnaces are energy efficient cabinets. They use the conduction, convection or black body radiation processes. The inside of the muffle furnace is usually made up of brick and the ceramic, while the outside is made up of the steel. Here we keep the crucible where our sample get heated by the heating elements. Coming to the procedure, in this we need to find out the weight of the clean dry crucible. Place about 2 grams of the sample and weigh this to find out the accurate weight of the sample taken. Carefully place the weighed crucible over electrical burner or the normal burner. The crucible should be partially opened. The sample will get charred with initial expulsion of smoke. Place the crucible in a muffle furnace and heat to 600 degrees centigrade. Keep it for 2 hours. At this temperature, all organic matter will be burnt, leaving behind minerals. Remove the crucible from the furnace carefully and cool it in the desiccator to room temperature and weigh again. What is obtained after complete combustion of a sample is the total ash. It comprises of 2 portions. The portion that is soluble in dilute acids contain all essential minerals and that is useful portion of the ash. Other portion which is insoluble in the dilute acid consists of mainly sand and silica. For the most part, it represses impurity or the adulteration. Sample preparation. Accurately weigh a clean dry crucible. There are different types of crucibles used, that is quartz, pyrex, porcelain, steel and the platinum. Selection depends on sample being analyzed and the furnace temperatures used. Most widely used is the porcelain, relatively inexpensive, resistance to high temperatures, that is less than 1200 degrees centigrade and easy to clean. This crucible is ceramic or the metal container in which metals or other substances may be melted or subjected to very high temperatures. Next is the weighing the sample. Add a known quantity of the food sample to the crucible. Record the combined weight of the crucible and the sample, which is taken as W2. Next is the drying. Pre-dry the sample in an oven at around 100 degrees centigrade to remove moisture. This step is optional but can help to prevent the spattering during assaying. Spattering means the small drops of liquid, especially they are very noisy when they spatter. Samples are usually 1 to 10 grams and solid foods are finely ground and carefully mixed. Before ash analysis, samples high in moisture that is dried to prevent the spattering. The samples which are high in fat content are defatted by solvent extraction, which facilitates the release of the moisture and prevents spattering. Avoid contamination of samples by minerals in grinders, glassware or crucibles. Next is the ashing. Place the crucible with the dried sample in the muffle furnace. Heat the furnace gradually to a temperature of 500 to 600 degrees centigrade. The sample is kept at the temperature until complete combustion of the organic matter is achieved, leaving behind white or grey ash. The process typically takes a few hours. Next is the cooling and weighing. Allow the crucible to cool in a desiccator to prevent moisture absorption from the air. Weigh the cooled crucible with the ash residue, which is taken as W3. This is the coal sample which is heated in the furnace at 500 to 700 degrees centigrade and we can see the ash residue. This is the diagrammatic representation. We weigh the sample in the crucible. The crucible is placed on the stove for charring and then it is placed in the muffle furnace for complete burning of the organic matter. We get the white grey ash that is weighed. Ash content provides vital information towards the nutritional value of food and can be used as an indicator on how processed different food items are. More processed foods tends to have the higher ash content when compared to the natural foods which have the lower ash content. For example, pure oil and fats can have an ash content low as 0%, whereas processed dry meats can contain up to 12% ash content. Processed foods are gaining popularity due to their affordability and the scalability. They are recognized for their adverse health outcomes. They are high in salt, saturated fats, fatty acids and sugar. Excess of these ingredients has been shown to increase the risk of developing certain health issues, which includes obesity, cancer, cardiovascular diseases. On the other hand, processed foods can also be beneficial. They reduce the risk of foodborne pathogens that causes health issues. Overall, it is vital to understand how much ash content is present in your food to understand these nutritional factors. Types of ash. Total ash represents all inorganic residues. Acid insoluble ash, the portion of ash that is insoluble in the dilute hydrochloric acid, that is HCl, used as an indicator of dirt and a sand contamination. Next is the water soluble ash, portion of the ash soluble in water, indicating the presence of the water soluble minerals. What do you mean by dry ash and the wet ash? It refers to the different methods for analyzing the inorganic residues remaining after the combustion of a sample. These methods are used to determine the mineral content in the food and other materials. Now coming to the calculations of ash content. Ash content percentage is equals to weight of the ash, that is W3 minus W1 by weight of the wet sample, that is W2 minus W1 into 100, where W1 is the weight of the empty crucible, W2 is the weight of the crucible with the wet sample and W3 is the weight of the crucible with the ash. If a sample weighs 10 grams including the crucible alone weighs 5 grams and the crucible with the ash weighs 5.5 grams. Ash content percentage is equals to weight of the crucible with the ash, that is given as 5.5 grams minus weight of the empty crucible, by weight of the crucible with the wet sample they have given us 10 grams minus weight of the empty crucible, that is 5 grams into 100, that is 0.5 by 5 into 100, we get 10% of the ash content. Based on the percentage of ash content, you have a sample weighing 5 grams before incineration and after ashing the residue weighs 0.2 grams. What is the percentage of ash content in the sample? The formula for ash percentage is equals to weight of ash by weight of sample into 100, that is weight of the ash that is given as 0.2 grams, we need to substitute here 0.2 by weight of the sample is 5 grams into 100 is equals to 4% of the ash content in the sample. Next is the correction for the moisture content. A food sample has the initial weight of 10 grams and the moisture content is 15. The ash content calculated without moisture correction is 2%. What is the ash content after correcting for moisture? First we need to calculate the dry weight of the sample. The formula for the dry weight is equals to sample weight into 1 minus moisture content in percentage. Here they gave the moisture content is 15. We need to convert into percentage, that is 0.15. Dry weight is equals to 10 into 1 minus 0.15. Then we will get the dry weight is 8.5 grams. Now we need to calculate the corrected ash percentage. The formula for it is ash percentage by dry weight percentage into 100. They have already given the ash percentage, that is 2, and we got the dry weight percentage, that is 0.85 into 100. We get the ash content after correcting for moisture is 2.35%. Next, coming to the mass loss during ashing. You begin with a sample of 6 grams and after ashing 1.2 grams remain as an ash. Calculate the percentage of mass loss during ashing. Mass loss percentage formula is equals to initial mass minus ash mass by initial mass into 100. What is the initial mass they have given is 6 grams minus initial mass is 1.2 grams by initial mass is 6 grams into 100. We get 80% of mass loss during ashing. Next, coming to the dry matter calculation. A sample weighs 20 grams and its moisture content is 12%. What is the weight of the dry matter in the sample? Dry matter is equals to sample weight into 1 minus moisture content percentage. It is converted into percentage, that is 0.12. Now dry weight is equals to the sample weight is 20 grams into 1 minus 0.12 is equals to 17.6 gram, that is the weight of the dry matter in the sample. Next, coming to the recovery rate in ashing. You know that theoretical mineral content of a food sample should be 5%, but after analysis you measure it to be 4.5%. What is the recovery rate of your ash analysis? Recovery rate is equals to measured ash content by theoretical ash content into 100. What is the measured ash content they have given is 4.5 by theoretical ash content is 5.0 into 100. We get 90% of the recovery rate of your ash analysis. The ash content can be expressed on either a dry or wet basis. The percentage ash on dry basis is equals to weight of the ash by weight of the dry sample into 100. Percentage ash on wet sample basis is equals to weight of the ash by weight of the wet sample into 100. The following data was obtained on a sample of Hamburg sample weighs 2.03 grams. Weight after drying is 1.0781 grams and weight of the ash is 0.0233 grams. What is the percentage of ash on wet basis and a dry basis method? Wet basis ash percentage is equals to, this is the weight of the ash, this is common for both, and weight of the wet sample is equals to, this is 2.034 into 100. We get the percentage on wet basis is equals to 1.15%, and dry basis ash percentage is equals to weight of the ash, that is 0.0233 by weight of the dry sample, that is 1.0781 grams into 100. Then we get Dry basis ash percentage is 2.16%. Applications for nutritional analysis, estimating the mineral content and the nutritional value in the food analysis. Next is the quality control, monitoring the purity and the quality of the food products, and the regulatory compliance, ensuring the product meet legal standards for ash content. Next are the advantages and limitations. Advantages are simple and widely applicable and provides a direct measure of the total mineral content. Limitations is require careful handling and precise temperature control to avoid loss of the volatile minerals or incomplete combustion. It's also time consuming as the ashing process can take several hours. If you like the video, please do like, share and subscribe.